Morning, everyone. Today we are starting chapter 11. We are starting with simplifying radical expressions. Now, radical is just another word for square roots. So what we're going to be doing today is simplifying terms with square roots in them. Now, it says the square root of a product means multiply, equals the product of the square roots of the factors. So what that means, or what that looks like, is that if we have the square root of a and b, a is really a times b, or ab, we can split that into the square root of a times the square root of b. An example of that is the square root of 4x equals the square root of 4 times the square root of x. We know what the square root of 4 is. We know that that's 2. Then we have the square root of x. Now, when we have a square root, the square root sign is the radical. The 8, or the number inside, is called the radicand. So let's try some of these. First one, we have the square root of 32. Now I know that that is not a perfect square. So what I'm going to do is I'm going to split this into what we know. I know that 32 is, we can multiply 8 times 4. Now I can find the square root of 4 because that is a perfect square. The square root of 4 is 2 times 2. So now I know that I'm going to have a 2. Here we can split that into 4 and 2. We can't find the square root of 2, but we can find the square root of 4, which is again 2 times 2. So what we have then is a factor 2 times 2 with a square root of 2. That's what we have left over. Now I know that I can do 2 times 2, which is 4, and we just have that square root of 2 left over. So my answer is 4 square root 2. Next one, we have a letter and a number in there. I know that this is the square root of 9 times the square root of x cubed. So the square root of 9 times the square root of x cubed. Now I know that the square root of 9 is 3 times 3. X cubed is really just 3 x's. Now 2 of those x's is going to make a squared, so I'm going to circle those. I'm also going to circle the 2 3's, because now what I have is 3, a factor of 3, a factor of x, and what I have left over is an x that I can't factor anymore. So my answer then is 3x square root x. 72. Well, again, that is not a perfect square. I do know that I can split up 72 into 8 and 9. So I'm going to do the square root of 8, the square root of 9. I know that the square root of 9 is 3 times 3. So I found one of the factors. Then again, I can split up 8 into 2 and 4. I can split up 4 into 2 times 2. So I have factors of 3, factors 2. So I'm going to have 3 times 2, left over a square root of 2. 3 times 2 is 6. times the square root of 2. Here we have the square root of 25 times the square root of x squared. 25 can get split into 5 and 5. X squared, well, we have the square root of a square, so those are the opposites. That's going to get split into x times x. So really all we have here is 5, which is the square root of 25, and x, which is the square root of x squared. So really we just have 5x. Alright, the next one we're going to do is multiply these radicals. So really, remember when we said like this was really just a combination of the square root of 16 times the square root of x? Well, now we're going to do the opposite. We're going to combine them. So 6 times 6 would be the square root of 6 times 6 under the radical, which is actually the square root of 36. 36 can be split into 6 and 6. So our answer is just the square root of 36, which is 6. Here we got a little bit bigger one. First of all, I see this 3 on the outside, so that's going to stay on the outside. So I'm going to put that 3 there. Then on the inside of my radical, I'm going to have 7xy squared and x. So now what I have inside is I have a 7, which is a prime number. I have 2 x's, so x squared, and I have a y squared. So then if I split those up, x squared is x times x, y squared is y times y. So I'm going to take an x out. Remember, I still have the 3. I'm going to take an x out. Then I'm going to take a y out. And then what I have left inside is just 7. So my answer is 3xy times the square root of 7. Next one, I'm going to make one big square root. So I have 75xy times 2x cubed. So now I'm going to factor these out. 75, I know, can factor to 25 and 3. I have an x, a y, a 2, and then 1, 2, 3 x's. So 25 can factor out to 5 times 5, which is a factor that I'm going to have, so 5. 3 can't be factored. I know I have an x, and then 2 more x's. So really then I just have 2 pairs of x's, so I have an x times an x. And then what I have left over is 3 times 2 times y. So 5, x times x is x squared. Inside I have 3 times 2, which is 6, y with the 6. Here again we have 4 already outside, so I'm going to leave that out, so 4. Then we have on the inside of our square root 3x times x. So on the inside here we have x and 3. X times x can be put together. So I know I can take out an x, so I'll have still 4 I'll take out the x, so 4x, and on the inside I still have 3. Here the square root of now 2x cubed times x. X cubed can be split into 1, 2, 3 x's. Then we have 1x here and just a 2 here. X can be grouped into those, or two groups of 2 x's, so I know I have 1x here times 1x here. Then what I have left on the inside is just 2. X times x becomes x squared, square root of 2. Last three, we are using the quotient property of radicals. So again, this is kind of the same thing as multiplication. If we have the square root of something, a fraction, what we can do is square root the top, the numerator, and the denominator. So the square root of 16 in this case is 4, square root of 25 is 5, so it becomes 4 over 5. In this case, we can do the square root of 13 divided by the square root of 100. When we simplify this, 13 is a prime number, so all we need to do is just leave that as the square root of 13. I know the square root of 100 is 10, so I'm just going to find the square root of 100 there. So the square root of 13 divided by 10. Here we have the square root of 7 over the square root of x squared. Square root of 7 is a prime number, or 7 is a prime number, so I'm just going to leave that, square root of 7. Divided by the square root of x squared. The squared and the square root cancel out, and we're just left with x. Lastly, we have the square root of 1 over the square root of y squared. Now 1 is a perfect square. 1 times 1 gives us 1. So our square root of 1 is actually 1. The square root of y squared, the squared and the square root cancel out. We're just left with y.